Hello, dear friend. Now you will listen to the answers to the questions that come to mind before going to bed. Please don't forget to subscribe to get the latest sleep facts right away. Lie back and enjoy listening. Why is the value of money determined by gold? When we talk about the value of money, we most often think of gold. Since ancient times, this metal has been considered a symbol of wealth, power, and reliability. But why did gold become the measure of value and not, say, silver, iron, or copper? The answer lies in a combination of chemical properties, rarity, and human psychology. Gold is unique in its nature. It does not rust, does not tarnish, does not dissolve in water, and almost does not enter into chemical reactions. If you put a gold coin in the ground for 1,000 years, it will hardly change. This makes gold an ideal guardian of value, a symbol of eternal wealth. Other metals lose their luster over time. They break down. But gold remains unchanged, as if time does not go by for it. In addition, gold is relatively rare, but not so rare as to be unattainable. It can be mined, melted, and separated, but it cannot be printed out of thin air. It is this combination of rarity and accessibility that has made gold an ideal base for exchange. In ancient times, people gradually came to the idea that gold is a convenient measure of value. It does not deteriorate. It is easily recognized, and it can be stored in any quantity. When the first states and trade routes appeared, gold became a universal language of exchange. A trader in Egypt, Greece, or China understood the value of a gold bar, even if he did not know the language of the interlocutor. Gold coins began to be minted about 3,000 years ago. They carried not just metal, but trust. After all, each coin symbolized a promise. I'm worth a certain amount of labor and resources. Over time, however, the economy has become more complicated. It has become inconvenient to store and transport large amounts of gold. Then the first paper money appeared. Receipts, which were issued by banks or rulers in exchange for real gold stored in their vaults. A person could come and exchange paper back for metal. This is how the idea of the gold standard arose. Each banknote represented a promise to issue an equivalent amount of gold. This principle lasted until the 20th century. For example, in the early 1900s, an American dollar could be exchanged for 1/20th of an ounce of gold. People trusted money because they knew there was real value behind it, the shiny metal in the vault. This trust is the foundation of the entire monetary system. But with the growth of global economies and trade volumes, gold has become scarce. It was impossible to print more money than gold was mined. And when there were wars or crises, countries needed flexibility, the ability to issue more money to support the economy. As a result, in 1971, the United States finally abandoned the gold standard, and the whole world followed them. Since then, money has stopped being directly dependent on gold. Their value is no longer based on metal, but on the trust of the people and the stability of the state that produces them. We call it fiat money. From the Latin fiat, let it be. That is, The value of money exists because everyone agrees to recognize it. However, gold has not lost its magic. Even in the era of digital currencies and bank cards, gold remains a symbol of reliability. Central banks still keep gold reserves, considering them to be insurance against crises. When the global economy is unstable, the price of gold rises. People look for protection in it, as ancient traders once did. Interestingly, attempts to replace gold with other materials have been made more than once. There were copper and silver standards, and there were experiments with uncoated paper systems, but only gold has managed to combine the three main qualities of ideal money: stability, rarity, and universal trust. What is a promotion? A share is a small part of a company, a piece of its property. When you buy a share, you become a co-owner of the company, even if only for a tiny fraction. And with this share, you get the right to a share of the profits, participation in the fate of the company, and, in a sense, a voice in its management. But to understand what an action really is, you need to look a little deeper into the history of money, trade, and human faith in the future. Once upon a time, businesses were owned by a single person or family. If they needed to expand, they borrowed money from bankers or rich acquaintances. But in the 16th to 17th centuries, trade grew rapidly, and the old methods stopped working. Huge sea expeditions, transportation of goods across oceans, all this required huge investments. And then an idea came up. What if we collect money from a lot of people and then divide the profits between them? Thus, in 1602, the world's first joint stock company, the East India Company, appeared in Amsterdam. She was selling stocks, shares in future earnings from trade with India. Any merchant, craftsman, or even a dock worker could contribute money and become a co-owner of the enterprise. In return, he received a document confirming his share. A share. If the company earned money, he received a portion of the profits, dividends. If she suffered losses, she lost money. Over time, this idea changed the whole world. The actions allowed thousands of people to pool their resources to create huge projects. Railways, factories, banks, telegraphs, and later airlines, technology companies, and even space programs. This is how the modern economy was born, where capital belongs not only to the rich, but to everyone who is willing to take risks. An action is not just a piece of paper. This is a legal proof of ownership. There are ordinary shares. They give the right to vote at shareholders' meetings and a share of the profits. There are also preferred ones. They usually do not give voting rights, but provide fixed payments as on a deposit. Companies can issue millions of shares, each of which is worth a certain amount. The share price is constantly changing. It is determined not by the company itself, but by the market, that is, the people who buy and sell. If the majority believes that the company will grow, the share price rises. If in doubt, she falls. Therefore, the stock exchange is not just a place where securities are traded, but a living reflection of human expectations, fears, and hopes. When you buy a stock, it's like you're betting on the future of the company. You believe that it will be successful its profits will grow, and with it, your share will grow. But with faith comes risk. If things go badly, the stock price will fall, and your investment will become worthless. This makes the stock market look like an ocean. It can be calm, but it is also capable of sudden storms. Stock exchanges were created so that stocks could be freely bought and sold. The most famous is New York, where giants like Apple, Tesla, or Coca-Cola are traded. There are London, Tokyo, Moscow, and many others. Exchanges are places where investors and businesses meet, where the value of a company turns into numbers running across screens. Interestingly, a modern investor often does not hold a share physically. Everything happens digitally. The number of shares and their value are displayed on the account in the brokerage application. But the essence remains the same. You own part of the business. Stocks can also be a way to finance startups. Young companies sell shares to investors in order to receive funds for development. Sometimes it ends with a fantastic success. A stock bought for $1 can grow to thousands. But more often, everything is much more modest. The market requires patience and common sense.
Why does a cactus have needles? Cactus is one of the most unusual plants on Earth. He lives where others don't even try to survive, under the scorching sun, among rocks and sand, where it may not rain for months. And yet, the cacti feel confident there, as if the desert itself was created for them. Their main secret is needles. They seem dangerous and prickly, but in fact, they are a surprisingly wise adaptation of nature, which hides a whole story of survival. Once upon a time, the ancestors of cacti looked like ordinary plants, with leaves, stems, and flowers. But the climate on Earth was changing. Where it used to be humid, it was getting drier. Those plants that could not adapt to the lack of water became extinct. But cacti have taken a different path. They have learned to conserve moisture, store it, and protect it. The first thing that is changed in future cacti is the leaves. The leaves usually evaporate a lot of water through small pores called stomata. In hot climates, this meant death. The sun dried up moisture faster than the plant could get it. Then nature came up with a clever solution. The leaves gradually shrank and eventually turned into needles. So the plant almost stopped losing moisture. But the needles didn't just replace the leaves. They have taken on several vital functions. The first is protection. There are many animals in the desert that need moisture, and there is a lot of it in a juicy cactus. Its stem, like a sponge, stores water accumulated during rare rains. Without the thorns, he would have just been eaten. Try biting a cactus, and you'll immediately understand why this is a bad idea, even for a camel. The second function is shade and cooling. At first glance, the thorns are thin and useless against the heat. But when there are many of them, they create a light shade around the plant and lower the surface temperature. It's like a miniature umbrella, made up of thousands of thin spokes. Under the blanket of needles, the air moves more slowly. Evaporation decreases, and the cactus remains cool. The third function is to collect moisture. In some species, thorns can catch droplets of mist and dew. Water condenses on their surface and rolls down to the roots. So, even in rainless areas where the air is barely moist, the cactus gets a sip of life-giving moisture. The fourth function is masking. Thorns help the plant blend in with its environment, especially if they are grey, yellow, or brown in color. For animals looking for food, such a cactus may look like just a rock or a withered bush. Interestingly, different species of cacti have invented their own types of needles. For some, they are long and sharp, like sewing machine needles. For others, they are short and soft, almost fluffy. There are even cacti whose spines are light and reflect the sun's rays like mirrors. And there are those who have them forming dense fur coats that protect them from the night cold. But if a cactus doesn't have leaves, then who does photosynthesis for it? Converts sunlight into energy? The answer is the stem. In cacti, it is green, thick and juicy, and it is in it that the whole process of life takes place. The stem is both the water storage, an energy factory, and a solid support. The needles are just guards, guarding his treasure. The shape of the cactus is another masterpiece of nature. Round and cylindrical shapes help to evenly distribute the heat of the sun, and the thick peel reduces moisture loss. Even the stomata, the very pores for breathing, open in cacti not during the day, as in ordinary plants, but at night, when the air is cooler. This way, less water evaporates. Cactus needles have always been something of a mystery to humans. They have both beauty and danger. The Indians used thorns as needles, hooks, and ornaments. And in the modern world, botanists see them as an amazing example of how life can adapt to the harshest conditions. What are gases? Gases are one of the three basic states of matter, along with solid and liquid. We encounter them every day without even noticing it. The air we breathe, the steam over a cup of tea, the carbon dioxide that bubbles in soda are all gases. They are invisible, mobile, and at the same time play a huge role in all processes on Earth, from respiration to climate. To understand what a gas is, you need to imagine how matter works at the level of the smallest particles, atoms, and molecules. In a solid, the particles are tightly pressed against each other and oscillate in place. They are also nearby in the liquid, but they can slide freely, flowing from shape to shape. But in a gas, everything is different. Its molecules are far from each other and move chaotically at high speed. That is why the gas has neither a shape nor a constant volume. It fills the entire space in which it is located. If you open a perfume bottle, the fragrance spreads quickly through the room. This is an example of the movement of gas particles. The fragrance molecules hit the air molecules and spread everywhere. This process is called diffusion, which is the property of a gas that tends to fill the available space evenly. Gases have other amazing properties. For example, they are compressible. If you reduce the volume of the vessel, the pressure inside will increase, because the particles will collide more often. Pumps, cylinders, and even our lungs work on this principle. When we inhale, the chest expands, the pressure in the lungs drops, and the air itself flows in. When we exhale, the volume decreases, the pressure increases, and the air comes out. Scientists gradually discovered the basic patterns of gas behavior. Back in the 17th century, the English physicist Robert Boyle noticed that if you reduce the volume of gas by half, the pressure will double. Later, Jacques Charles and Joseph Gay-Lussac found out that gases expand when heated and contract when cooled. These discoveries formed the basis of the Boyle-Mariotte law and Charles's law, which describe how pressure, temperature, and volume change. But what makes gases so important for life? Let's start with the air. It is a mixture of several gases, approximately 78% nitrogen, 21% oxygen, and slightly less than 1% carbon dioxide, argon, and other components. Oxygen is necessary for all living beings. Without it, breathing and gorenje are impossible. Nitrogen, although calm, plays a key role in building proteins and DNA, and carbon dioxide serves as a building material for plants. They absorb it from the air and, using the energy of the sun, create nutrients. Gases also regulate the Earth's climate. There are so-called greenhouse gases in the atmosphere: water vapor, carbon dioxide, methane. They retain some of the heat radiated by the planet, preventing it from escaping into space. Without this effect, the Earth would be cold and lifeless. But if there are too many greenhouse gases, the temperature rises and global warming begins. Gases also play an important role in engineering. For example, compressed air is used in train braking systems, and oxygen and acetylene are used in welding. Helium fills balloons because it is lighter than air, and carbon dioxide makes drinks fizzy. Even in space, gases do not disappear. Stars, including the Sun, consist mainly of incandescent gases in a state of plasma. There are also special gases that behave strangely. For example, inert gases, helium, neon, argon, krypton, xenon, they almost do not enter into chemical reactions, which is why they are used in lamps and electronics. And there are poisonous ones, like chlorine or carbon monoxide, which are dangerous even in small quantities. The science of gases is not limited to physics. It permeates both medicine and cooking. When we bake bread, yeast releases carbon dioxide, which raises the dough. When breathing, the human body absorbs oxygen and releases carbon dioxide. Even our emotions are related to breathing. A deep breath calms down, and short, intermittent breathing signals anxiety. What did Red Indians like to eat? When we say Indians, I often see pictures from old movies: chiefs in feathers, hunting bison, bonfires and drums. But behind this romantic picture there is a surprisingly rich and diverse culture, including culinary. What the Indians ate depended on the region, climate, and traditions. Some lived in the icy lands of Canada, others in the hot forests of the Amazon, or on the dry plateaus of Mexico. But they all had one thing in common: the ability to take everything from nature without destroying it. The basis of the diet of most Native American peoples were the three sacred sisters: maize, corn, beans, and pumpkin. These three plants were grown together, and they helped each other grow. The corn stretched upward, serving as a support for the beans. The beans, in turn, enriched the earth with nitrogen, and the wide pumpkin leaves protected the soil from the sun, retaining moisture. It was an almost perfect example of natural farming. Corn had a special place in the Indians' lives. It was eaten boiled, baked, and ground into flour, which was used to make tortillas, porridges, and even drinks. Among the Maya and Aztecs, corn was considered a sacred gift from the gods. According to legend, the first man was created precisely from the dough of corn kernels. Maize was used to make tamale, a dough wrapped in corn leaves and steamed, a dish that has survived to the present day. Beans and pumpkins supplemented the diet with proteins, vitamins, and fats. In combination with corn, they provided an almost complete set of nutrients, the natural embodiment of a balanced diet. Sometimes chili peppers, wild herbs, and seeds were added to the dishes, spices that gave the food taste and warmth. But, of course, the Indians were not limited to plants alone. Hunting and fishing occupied an important place in their lives. On the Great Plains, the main prey was bison. This huge animal provided meat, fat, bones, skin. Literally everything went into action. The meat was dried in the sun or smoked, turning into pemmican, a nutritious reserve that could be stored for months. It was prepared as follows. Meat was cut into thin plates, dried, ground into powder, and mixed with fat and berries. It turned out to be a high-calorie dish that saved hunters and warriors on long hikes. In the north, where corn and beans did not grow, the Indians ate mainly fish and meat from northern animals, deer, moose, seals. They were able to smoke and freeze food long before the advent of refrigerators. In the coastal regions of the Pacific Ocean, salmon was the main source of wealth. It was caught in huge quantities, dried and salted to feed in winter. And in the South, in Central and South America, where it was warm and fertile, the diet was much more diverse. They ate avocados, tomatoes, peppers, cocoa, pineapples, papaya, and cassava, the root vegetable used to make flour. The Indians used cocoa to make a bitter drink with pepper and spices, the ancestor of modern chocolate. It was considered the drink of the gods and was served only to chiefs and warriors. Some tribes collected wild berries, nuts, mushrooms, and edible roots. In North America, acorns were especially valued, which were used to make flour by washing them to remove the bitterness. In the Southwest, cactus fruits were eaten, juicy, sweet, and very healthy. The Indians paid special attention not only to food, but also to the method of its preparation. They didn't have iron pots or stoves, but they did have craftsmanship. They cooked their food in pits by heating stones or used ceramic pots by placing them on coals. Many dishes were prepared slowly for several hours to preserve the taste and softness. For the Indians, eating was not just a way to satisfy hunger. It was part of a ritual and gratitude to nature. Before hunting or harvesting, they brought gifts to the spirits of the earth and animals, asking for permission to take only as much as they needed. This philosophy of respect for nature permeated their way of life. How did the Great Lakes form? The Great Lakes are one of the most impressive natural wonders of North America. 5 giant bodies of water, Superior, Huron, Michigan, Erie, and Ontario, together contain almost a fifth of the planet's total fresh water. It's like the inner ocean of a continent. Storms, beaches, ships, lighthouses, fish, and even its own climate. But how did these colossal water bowls form? To understand this, you need to go back tens of thousands of years, to an era when the Earth was covered with ice. About 2 million years ago, the Ice Age began. The planet's climate cooled, and huge masses of ice began to move from the north, gradually covering Canada and the northern part of the United States. The glaciers were up to 3 kilometers thick, like giant rivers of ice, slowly but inexorably creeping forward. Under their weight, the earth buckled. The mountains were ground to dust, and the valleys turned into deep furrows. Where the waters of the Great Lakes splash today, such ice masses once lay. They moved, grinding rocks, clay, and soil like a giant grater. Everything that stood in the way of the ice was crushed and squeezed out, leaving behind traces, deep hollows and hills of clay and sand. Scientists call this process glacial erosion, which is the destruction of the Earth's surface by ice. When the climate began to warm up about 12,000 years ago, the glaciers began to retreat. And then another equally important stage began: melting. Billions of tons of ice turned into water, filling lowlands and hollows hollowed out by glaciers. This is how the first prototypes of the Great Lakes appeared. At first, these were huge glacial seas where meltwater flowed from the north. For example, on the site of Lakes Superior and Huron, there was a single ancient body of water, Lake Agassiz. It stretched for hundreds of kilometers, and its shores changed as the glaciers melted further and further. Over the millennia, the ice began to melt, and the earth began to rise slowly, freeing itself from gravity. Then, the water began to look for new ways, connecting, flowing, and creating a system that we today call the Great Lakes. Each of the 5 lakes has its own history and peculiarities. Lake Verkney is the largest and deepest. It appeared first and is above the rest, feeding them with its waters. Its shores are rocky, and its waters are cold and clear. Huron and Michigan are connected by the Mackinac Strait, and from the point of view of geology, they actually represent one huge lake, divided only conditionally. Erie is the smallest, but the warmest, which is why it freezes quickly in winter and bursts with life in summer. Ontario is the last in the chain, and it is from it that the St. Lawrence River flows, carrying water to the Atlantic Ocean. This system is surprisingly balanced. The water entering Lake Superior goes a long way through all the others, and only reaches the ocean after decades. The Great Lakes are like a giant staircase, down which fresh water slowly descends, connecting the continent with the sea. Glaciers not only hollowed out the basins, but also shaped the landscape around them. After their retreat, there were huge fields of stones, sandy plains, and moraine hills. These lands later became fertile as the glacier crushed the rocks and left a mineral-rich soil. Therefore, it is here, in the Midwest, that some of the best agricultural areas of the United States and Canada have grown up. Interestingly, the Great Lakes are still living their geological lives. The Earth's crust, freed from ice pressure, is slowly rising by about 1 centimeter per year. Because of this, the shorelines of the lakes are also gradually changing. Somewhere the water recedes, opening up new land areas, and somewhere, on the contrary, it rises, flooding the lowlands. Is all the rice white? When we imagine rice, most often in our imagination, there is a white, shiny grain, light and neutral in taste. But in fact, white rice is just one of the many types of this amazing grain. Rice can be brown, red, black, or even purple, and each type has its own history, processing method, and nutritional characteristics. To understand why rice can be different, you need to figure out how it grows, what is done with it after harvesting, and what role it plays in the culture of different nations. Rice is one of the most ancient plants cultivated by humans. It has been cultivated for more than 10,000 years, and Southeast Asia, the Yangtze and Ganges river valleys, is considered its homeland. There, in a warm and humid climate, people first noticed that wild rice seeds can germinate and yield crops if they are planted in flooded fields. Since then, rice has become the staple food for half of the world's population. To understand why rice comes in different colors, it's worth looking inside its grain. Each grain of rice consists of 3 main layers: husk, bran, and endosperm. The husk is a rough outer shell that protects the grain from pests and moisture. It is always removed because it is inedible. Below it are the bran, a layer where vitamins, minerals, and oils are concentrated. And in the center is the endosperm, which consists mainly of starch. It is he who gives the grain its white color after grinding. If, after removing the husk, the grain is left as it is, then brown rice is obtained. Its color is light brown because the bran remains in place. Such rice is considered more useful. It contains B vitamins, fiber, and magnesium. But it also has a disadvantage. It takes longer to cook and has a light, nutty taste that is not familiar to everyone. When the bran is completely removed, the grain turns white. This process is called sanding. White rice looks neat and lasts longer because the oils contained in the bran become rancid over time. However, when grinding, most of the nutrients are lost. Therefore, in some countries, such as the USA, white rice is additionally enriched with vitamins and iron. In addition to white and brown, there are also rarer varieties. Red rice gets its color due to substances called anthocyanins, which are found in the shell of the grain. It is especially popular in India, Sri Lanka, and Thailand. Its taste is slightly sweet and rich. Black rice, or imperial rice, is grown in China and Southeast Asia. It was once considered so valuable that only the emperor and his family were allowed to eat it. Black rice is rich in antioxidants, the same ones found in blueberries, and turns dark purple after cooking. There is also golden rice, which is the result of modern biotechnology. It was developed by scientists by adding the genes of plants producing beta-carotene, a precursor of vitamin A. Such rice helps to fight vitamin deficiency in countries where people eat mainly rice. Interestingly, the color of rice affects not only its appearance, but also its taste and aroma. White rice is neutral and absorbs the taste of sauces and spices. Brown, denser and more fragrant. Red is slightly sweet, and black is almost a dessert. It is often used in sweet dishes, especially in Thailand. Cooking methods also vary. In Asia, white rice is most often steamed, as it turns out to be crumbly and retains its shape. In Japan and Korea, rice is boiled until it is slightly sticky, so that it is convenient for them to eat with chopsticks. In India, long, grain basmati is used, and in Italy, round grain arborio is used for risotto, which gives the dish a creamy texture. It is worth noting that not all white rice is the same, even in appearance. There are long grain, medium grain, and round grain varieties. Long grain remains crumbly. Medium grain remains slightly sticky, and round grain remains almost sticky, ideal for sushi or milk porridge. How does a banana tree grow? When we hear the words banana tree, we imagine a tall trunk covered with huge leaves and clusters of yellow fruits hanging down. But here's an amazing fact. A banana tree is not really a tree. From the point of view of botany, it is an herbaceous plant, one of the largest on the planet. It does not have a real tree trunk, although it looks mighty and tree-like. To understand how a banana grows and why it works this way, it's worth looking inside its green trunk and tracing the entire path, from a tiny shoot to a fruiting giant bunch. Bananas are native to Southeast Asia. There, in the warm and humid forests, people first noticed that this plant produces sweet and nutritious fruits. Over time, bananas have spread all over the world. They are grown in India, the Philippines, Africa, Latin America, and even the Canary Islands. But the principles of their growth are the same everywhere. A banana likes warmth, moisture, and a mild climate without strong winds. If you take a closer look at a banana plant, it becomes clear. Its trunk is not wood at all, but tightly folded leaf bases, or petioles. Scientists call this structure a pseudostem, that is, a false stem. It can reach a height of up to 8 to 10 meters, and that's why it looks like a tree. Inside the pseudostem is not wood, but a fibrous, moist mass that retains moisture and nutrients. The real heart of a plant is the rhizome, or underground trunk from which the roots extend. A new pseudostalk grows from this rhizome every year. When the old stem has fructified, it dies, and a new one grows in its place, as if the plant is reborn. That is why the banana plant lives a long time, although each particular stem bears fruit only once. The growth cycle of a banana begins with the appearance of a young shoot from the rhizome. It quickly stretches upward, unfolding more and more giant leaves. Each can reach 2 meters in length and almost a meter in width. These leaves grow spirally, wrapping around each other and forming a trunk. After 9 to 12 months, the plant becomes mature and ready to bloom. Banana blossom is one of the most beautiful sights in the tropics. A long inflorescence appears from the middle of the stem, which gradually hangs down. At first, a large purple bud is visible, similar to a drop or a heart. When the petals open, rows of small flowers appear from under them. One banana develops from each flower. The flowers grow in tiers. Those closer to the base bear fruit, and the upper ones dry out over time. A few months after flowering, banana clusters appear in place of the flowers. There can be from 50 to 200 fruits in one such bunch, and the total weight reaches 50 kilograms. Each row in the bunch is called a hand, and a single banana is called a finger. That's how it turns out to be a banana brush, a multitude of fingers connected in one hand. The fruits ripen within 3 to 4 months. In nature, bananas grow green and turn yellow only when ripe. Interestingly, wild bananas are not the same as the ones we eat. Their fruits contain a lot of hard seeds, and they are not always sweet. Modern cultivated varieties are the result of breeding. People have bred varieties without seeds that reproduce only vegetatively, that is, through shoots. After the bunch is ripe, the pseudostalk dies off. It is cut off, and a new shoot is already growing from the rhizome, which will give a new bunch in a year. This is how bananas grow on the plantation all year round. While one stalk is bearing fruit, another is just forming, and the third is still young and gaining strength. By the way, banana plantations are a whole science. Plants are planted in rows at a distance of about 2 meters, so that they have enough light and air. Each plant requires abundant watering, because a banana consists of 80% water. To protect against the wind, other crops are often planted nearby, or protective nets are put up, because strong gusts can tear large leaves or break the stem. What is olive oil? Olive oil is one of the most ancient products known to mankind. It is used in cooking, medicine, cosmetics, and even in religious rituals. When we see a bottle of golden or green oil, it's hard to imagine that every drop is the result of thousands of years of experience and labor, as well as a complex natural process. To understand what olive oil is, you should start with the tree from which it is obtained, and trace the entire path from the fruit to the bottle. The main source of oil is the olive tree, which is native to the Mediterranean. These trees can live for hundreds and sometimes thousands of years, withstand drought, and preserve fruits that provide food and oil. The fruit of the tree, the olive, contains up to 20% oil by weight. But it's not easy to get it. Olives need to be harvested, ripe fruits selected, washed, crushed, and squeezed. The taste and aroma of the future product depends on the quality of the raw materials. There are several categories of olive oil, and they differ in the way they are obtained. Extra virgin is the highest grade. It is obtained only by mechanical means, without chemical treatment and heating. The oil of this variety has a rich taste and aroma, often fruity or slightly bitter. It is considered the most useful because it preserves a maximum of antioxidants, vitamins, and natural compounds. There is also virgin, which is slightly inferior in quality, as well as refined oil, which is processed to remove bitterness and odors. This oil is suitable for frying, but loses some of its useful properties. In cooking, people use different varieties depending on the dish. They prefer extra virgin for salads and dressings, refined for frying. The olive oil production process begins with the harvesting of fruits. In the old days, olives were harvested by hand, dropping them on a cloth or tarpaulin. Today, vibrating combs are also used, which shake the fruits off the branches without damaging the tree. Then the fruits are washed and ground into a paste. Next, the paste is placed in special presses or centrifuges to separate the liquid from the pulp and water. The resulting oil is filtered to remove the remains of the fruit and bottled. Interestingly, olive oil is not only a food product. In medicine, it is valued for its healthy fats, especially monounsaturated fats and antioxidants that help lower cholesterol, protect blood vessels, and support heart health. In cosmetics, oil is used to moisturize the skin and hair. In religious traditions, it symbolizes purity, blessing, and health. In addition, the quality of the oil depends on the time of fruit harvest. Early olives produce an oil with a more intense taste and bitterness. It is saturated with phenols. Later fruits produce a soft, sweet oil, more neutral. The taste and aroma are influenced by the climate, the soil, and even the type of tree. There are more than 1,000 varieties of olives, each with its own character. Olive oil is rich in vitamins A, D, E, and K, as well as antioxidants such as polyphenols. It is easily absorbed by the body and helps maintain the balance of fats in the diet. Scientists believe that regular consumption of butter reduces the risk of cardiovascular diseases, supports brain function, and even slows down cell aging. Olive oil is indispensable in cooking. It can be used as a base for marinades, salad dressing, and an addition to soups and hot dishes. When heated, extra virgin loses some of its flavor, but retains healthy fats if the temperature does not exceed 180 degrees Celsius. In the Mediterranean countries, butter is the basis of almost every cuisine. It is present in simple vegetable dishes and in exquisite sauces. The history of olive oil is amazing. Back in ancient Greece and Rome, it was used to light lamps, treat wounds, and massage. It was believed that the oil strengthens the body and spirit. Today, these traditions have been preserved,
Olive oil remains a symbol of health, longevity, and harmony with nature. Do other planets move in the same way as Earth? When we think about the movement of the planets, we often think of the Earth. It rotates on its axis, creating day and night, and simultaneously moves around the Sun, forming the year. But what about other planets? Do they move the same way? Or does each planet live by its own laws? The answer is both simple and surprising. The laws are the same, but the speeds, sizes, and features of movement are different. To figure it out, you need to look into the basics of astronomy and understand what a planetary orbit and rotation are. All the planets of the solar system move in elliptical orbits, which were discovered by Johannes Kepler in the 17th century. Kepler formulated 3 laws. The first states that the planets move in ellipses, and the Sun is in one of the foci. The second is that the line connecting the planet to the Sun describes equal areas over equal periods of time, meaning the planet moves faster when it is closer to the Sun. The third law relates the period of a planet's rotation to the size of its orbit. The further away a planet is from the Sun, the longer it takes it to complete a full circle. Thus, all planets, from Mercury to Neptune, obey these laws. They revolve around the Sun, held by its gravity, but each has its own speed and period. For example, Mercury, the planet closest to the Sun, rotates in just 88 Earth days, while Neptune takes almost 165 years. The Earth in this row looks average, with a year length of 365 days and a speed of about 30 kilometers per second. The planets also rotate on their own axis, just like the Earth. This process creates day and night, but the speed and direction of rotation are different for everyone. Venus rotates backwards in the opposite direction of the Earth and makes one revolution in 243 Earth days. Jupiter's day lasts only about 10 hours due to its rapid rotation. The Earth is somewhere between these extremes. A day lasts 24 hours, and rotation goes from west to east. Another interesting feature is the tilt of the planet's axis. The Earth is tilted by 23.5 degrees, which creates seasons. Other planets have a different tilt. Uranus has an almost horizontal axis, almost 98 degrees. This means that on Uranus, summer and winter last for decades, and the polar regions receive continuous sun, or polar night. On Mars, the tilt of the axis is similar to that of Earth, so there is a change of seasons. The rotation and orbital motion of a planet depend on the mass, gravity of the Sun, and interactions with other bodies. Planets do not move in isolation in a vacuum. They are affected by the gravitational pull of the Moon, moons, other planets, as well as solar tides. Therefore, the orbits are not perfectly circular, but slightly elongated or slightly displaced.
Sometimes the gravitational interaction causes fluctuations, known as orbital resonances. For example, Jupiter affects asteroids in the belt between Mars and Jupiter, creating empty zones where there are almost no asteroids. Although the movement of the planets follows the same laws, the pace, direction, and climatic effects are different. Fast-rotating planets like Jupiter have strong atmospheric currents and hurricanes that can reach hundreds of kilometers per hour. Slow-rotating planets like Venus have quieter but stable atmospheres, where winds can be slow on the surface but turbulent in the upper layers. In addition to the planets of the solar system, there are also exoplanets orbiting other stars. Their motion also obeys the laws of gravity, but their orbits can be unusual, elongated, inclined, or even twisted due to the influence of neighboring stars. Some of them orbit so close to the star that they always face it with one side, like the moon facing the Earth. What is radio astronomy? Radio astronomy is an amazing field of science that studies the universe, not with eyes, but with the help of radio waves. If ordinary astronomy relies on visible light, which we see with our own eyes or through a telescope, then radio astronomers hear space at frequencies inaccessible to human vision. Thanks to this, they can observe stars, galaxies, and other objects hidden behind clouds of gas and dust that block light, but radio waves pass through them. The idea of radio astronomy originated in the early 20th century. In 1931, American engineer Carl Jansky accidentally discovered radio noise emanating from the center of the Milky Way while he was trying to study interference in radio communications. He realized that these were not interference, but signals coming from space. Thus began a new era. Scientists realized that radio waves carry information about what is happening in the far corners of the universe. Radio waves are part of the electromagnetic spectrum, just like light, X-rays, or microwaves. They can spread over millions and billions of kilometers, and that is why radio astronomers can hear objects located at a great distance from the Earth. For this purpose, radio telescopes are used, huge antennas capable of picking up the faintest signals from space. These devices often resemble giant saucers, up to hundreds of meters in diameter, pointing at the sky. Radio astronomy has revealed many mysteries. With her help, we learned about pulsars, rotating neutron stars that emit radio pulses with precise regularity. For the first time, radio astronomers have recorded the cosmic microwave background, the weak radiation left over from the Big Bang, which gives us information about the origin of the universe. They explored galaxies, active nuclei, and black holes, finding objects invisible in the optical range. The peculiarity of radio astronomy is that it allows you to see what is hidden. For example, the center of our galaxy is littered with gas and dust. No light passes through these clouds, and the conventional telescope will only show a dark spot. But radio waves travel freely through gas and dust,
allowing us to see clusters of stars, the movement of clouds of hydrogen, and the activity of the black hole at the center of the Milky Way. Radio astronomers often use interferometry, a method in which several radio telescopes are combined into one system. This allows you to create high-resolution images, as if you are looking through one giant telescope hundreds of kilometers in diameter. Using this method, the most detailed maps of distant galaxies and accretion disks around black holes were made. Radio astronomy also helps to search for exoplanets and potentially habitable worlds. Although radio waves do not transmit images, they allow us to measure the movement of stars and fluctuations caused by the presence of planets. Sometimes, scientists look for unusual radio signals that could indicate intelligent life beyond Earth. This area is called SETI, Search for Extraterrestrial Intelligence. An important property of radio waves is their ability to pass through the Earth's atmosphere. But for accurate measurements, radio astronomers prefer to build observatories in remote locations where there is less interference from cities. Sometimes, radio telescopes are placed in space, so the influence of the Earth's atmosphere disappears completely. The history of radio astronomy is a story of new discoveries and amazing finds. It allowed us to see the invisible, hear the faintest voices of the universe, study the formation of galaxies, the movement of hydrogen and molecules in nebulae. Without radio astronomy, we would not know about pulsars, radio galaxies, the cosmic microwave background, and many other phenomena. Why do words have certain meanings? Words are amazing tools that people use to convey thoughts, emotions, and knowledge. When we say the word house, we immediately imagine a building with roofs, windows, and doors, although the very combination of sounds, D-O-M, does not mean anything in nature. Why is this happening? Why do words have such meanings, and how are they fixed in the language? To understand this, you need to look at the history, psychology, and structure of language. Firstly, the meanings of words are not given by nature. They are created by society. A language is a system of signs, where each sign consists of a sound or written symbol, and the meaning that the community attaches to it. For example, in English, the word apple means apple, and in Russian it means apple. The sounds are different, but the concept is the same. This shows that the connection between sound and meaning is conditional. It develops historically and culturally. The history of the word plays an important role. Many words appeared because of specific events, habits, or associations. For example, the word computer used to mean a person who performs calculations, but today it is a machine. The meaning of the word has changed with the advent of technology, and society has agreed to a new interpretation. That is, the meanings of words evolve with the development of culture, science, and everyday life. Linguists identify several ways in which words gain meaning. One of them is a metaphorical transfer. For example, the word wing originally meant the organ of a bird, and later became used for parts of a building that are spread out, like a wing.
Another way is to borrow. The language borrows words from other peoples, and their meanings can adapt. For example, pizza came from Italy, but in many countries its meaning varies slightly, depending on traditions. The psychology of language also explains why words mean exactly what they mean. When a child learns to speak, he associates sounds with objects or actions. If you hear the word apple every time you see an apple, an associative connection is formed. Over time, this connection is fixed in the brain and passed on to culture. When several generations support this system, the meaning of the word becomes stable. In addition, the meaning of a word depends on the context. The same word can change its meaning depending on the situation. For example, the word key can mean an object that opens a lock, or an important concept in theory, and in sports, a certain element of the game. Context allows the language to be flexible and the words to be multi-valued, while maintaining understanding among native speakers. Over time, words are collected into lexical fields, groups of words connected by a common meaning. For example, the words forest, tree, grass, shrub form the field vegetation. This helps a person navigate the world faster and find the right concepts. The meaning of a word becomes part of this structure, and we begin to perceive it through a network of associations. Historical changes, social norms, and cultural influences all shape meanings. Words that were once jargon can enter the literary language. Words that denoted one object can expand or narrow their meaning. For example, the word mouse initially meant an animal, and with the advent of computers, it began to denote a device. In addition, the meanings of words are fixed through communication. When people use a word, they confirm its meaning. If the speaker and the listener understand each other, the meaning is fixed. If not, the meaning is clarified or changed. This is how language self-regulates and develops, while maintaining the ability to convey information accurately and efficiently. How do grass seeds spread? Grass seeds are tiny carriers of life, thanks to which plants spread and survive. At first glance, they seem simple, small, light, and inconspicuous. But each blade of grass uses unique strategies to ensure that its seeds end up in a new place where they can germinate. This process is the result of millions of years of evolution, and nature has developed a whole system of ways that ensure the survival and reproduction of plants. First, it's worth understanding that a seed is a miniature machine for procreation. Inside the seed is the embryo, the future herb, and around it are nutrients that ensure its growth in the first days after germination. The seeds are protected by a shell that prevents drying out and damage. But the seed will not reach the ground by itself yet. It needs transportation. And then a variety of distribution methods are included. One of the most famous ways is wind. Grass seeds are often light, with hairs, wings, or parachutes that allow them to be carried tens or hundreds of meters. A classic example is a dandelion. Its seeds are equipped with fluffy hairs that are held aloft like mini parachutes. A strong gust of wind carries the seeds far away from the parent plant, reducing competition and allowing colonization of new places.
Animals are another way. The seeds can cling to wool or feathers or be carried with food. For example, seeds with thorns or hooks easily get stuck on animal skins and fall elsewhere. Some herbs produce seeds inside fruits that are eaten by birds or mammals. The seeds pass through the digestive tract and end up in a new place along with the fertilizer, which increases the chance of successful germination. There is also water transport. The seeds of some herbs can float and be carried by streams of water. For example, reeds and some coastal grasses are adapted so that their seeds stay in the water for a long time without losing their viability. This method is especially effective in areas where seasonal flooding helps spread plants over large areas. An interesting independent method of distribution, called autochary, is also interesting. Some herbs use the power of their own seed or fruit. For example, the seeds of some types of legumes shoot out of the pod when it ripens and dries. The mechanism is similar to a miniature ejection throw, allowing the seed to fly several centimeters or even meters away from the mother plant. For a small seed, this is a long distance. Seed survival also depends on dormancy strategies. Many herbs produce seeds that do not germinate immediately. They can lie in the ground for weeks, months, or even years, waiting for suitable conditions: moisture, temperature, or lighting. This protects the offspring from drought, frost, or unpredictable weather. A variety of strategies spreads grass seeds over different distances and helps plants to develop new ecosystems. For example, steppe grasses often use wind, and forest grasses often use animals, because dense vegetation makes it difficult for air to move. In deserts and savannas, autochary and rapid growth after rain are important. Thus, each medium forms its own set of transport rules for seeds. In addition, the seeds can use human activity. People inadvertently transfer seeds on shoes, clothing, agricultural machinery, and vehicles. Sometimes this leads to the appearance of new species far from their native place, as happened with meadow grasses that have spread all over the world. From an ecological point of view, seed propagation is the key to maintaining biodiversity. It allows grasses to occupy new territories, restore ecosystems after fires, floods, or space disasters, and maintain animal nutrition. Without effective seed propagation, grass simply could not exist in diverse climatic zones. Who carved the faces on Mount Rushmore? Mount Rushmore in South Dakota is one of the most recognizable historical structures in the United States. The granite rock features the faces of 4 presidents: George Washington, Thomas Jefferson, Theodore Roosevelt, and Abraham Lincoln. These giant portraits have become a symbol of American history and national identity. But who was behind the creation of this colossal work of art? And how did they manage to turn the stone into a large-scale memorial? The idea to create a monument on the mountain belongs to Duncan McKinley Hunt, a sculptor from South Dakota.
At the beginning of the 20th century, Hunt wanted to perpetuate the legacy of American leaders and emphasize the role of these presidents in shaping the nation. He proposed a project that combined artistic vision and engineering skills. The project was supported by the federal government, which allocated funds for construction and also allowed to attract labor. Gatton Borglum, a renowned American sculptor, took over the artistic and technical management of the project. He was the chief architect and also actively participated in the work on the project. Borglum understood that the work would be unique. Granite rock does not forgive mistakes, and faces should be recognizable from a long distance. He carefully planned each stage, created models and layouts to make sure that the scale and proportions would be correct. The work began in 1927 and lasted until 1941, almost 15 years. A technique was used for the rock, which combined explosives and manual processing. At first, workers removed large chunks of granite using dynamite to shape the faces and their features. After that, sculptors and masons used hammers and chisels to carve out details: eyes, nose, mouth, and facial lines. Each element was checked using scale models to make the final work look right from the valley below. There were many workers working on the mountain: masons, engineers, and sculptors' assistants. The work was dangerous. The masons worked on narrow platforms suspended from the rock using ropes and scaffolding. Despite this, there were few tragic cases, although the project was considered extreme in terms of labor intensity and complexity. The choice of presidents for Rushmore was symbolic. George Washington is the first president and the symbol of the founding of the state. Thomas Jefferson is the author of the Declaration of Independence and a proponent of the ideas of democracy. Theodore Roosevelt is a reformer and a symbol of industrial progress, while Abraham Lincoln is a liberator of slaves and a symbol of national unity. These four personalities embody key stages in the history of the United States and its ideals. The monument was conceived not only as a work of art, but also as a tourist attraction and a symbol of national identity. Borglum and his team wanted to create something that would inspire people, remind them of the country's civic values and achievements. The height of each face is about 18 meters, the eyes reach 3 meters, and the noses are 6 meters. This scaling allowed the monument to be visible from a great distance and create an effect of grandeur. Rushmore granite is a very hard and durable material. Thanks to this, the memorial has withstood decades of bad weather, wind, and snow, preserving the shapes of the faces almost unchanged. During the work, engineers and sculptors took into account possible erosion, created drainage channels, and specially selected corners to minimize the destruction of granite under the influence of rain and ice. Interestingly, additional elements were planned, scenes and figures of historical events, but the project was shortened due to lack of funds and the outbreak of World War II. Nevertheless, the monument has retained its main idea: 4 majestic faces symbolizing the history and ideals of the United States.
How did cavemen make their tools? When we think of cavemen, we often imagine figures with spears or stones in their hands sitting by the fire. But how exactly did they make their tools? And why did these seemingly simple tools turn out to be so important for survival? The creation of tools by primitive people is an example of how observation, ingenuity, and the ability to work with natural materials allowed our ancestors to adapt to harsh conditions and gradually develop culture.
Cavemen used available natural materials: stone, bone, wood, and charcoal. Stones were the main source of tools because they could be easily machined to produce sharp edges. To do this, they used a method that modern archaeologists call plating, or the nuclear technique. One stone was struck against another to break off small pieces with sharp edges. These fragments became knives, scrapers, and spearheads. Especially important was flint, a hard stone that easily split, forming sharp blades. Flint tools made it possible to cut meat, leather, plants, and wood, which provided food, clothing, and shelter. Primitive people carefully selected stones, checking them for hardness and structure so that the tool was strong and sharp. Besides stone, animal bone and horn were used. They could be honed, sanded, and made into arrowheads, needles for sewing clothes, and fish hooks. Such tools were more flexible and lightweight than stone tools, but they required great processing skills. For example, a needle made of bone made it possible to sew animal skins, making clothes warmer and protecting them from the cold. Simple but effective techniques were used to work with the materials. The stones were hewn using blows from other stones or wooden hammers. Softer materials, such as wood, were processed with knives or stone scrapers. Sometimes a pressure method was used. A stone or bone exerted pressure on the material to chip off the desired pieces. These techniques made it possible to create tools of various shapes and purposes, from small knives to large chopping tools. Interestingly, the guns were not always made at hand. Primitive people understood the backup principle. They made several tools at once in order to have them if necessary. Many finds show that people carried stones and blanks with them that could be turned into tools at any time. This indicates planning and understanding of future needs. In addition to functionality, the tools reflected the ability to observe and analyze nature. For example, light tools made of bone or wood were chosen for fishing, and strong and sharp spear tips were used for hunting. Even the choice of a place to mine flint or wood was well thought out. People were looking for materials with the right properties, so that the tool would last a long time. With the help of tools, cavemen developed not only survival, but also a social life. Hunting required coordination and the transfer of knowledge and skills to the young members of the group. Stone, bone, and wood processing became part of the training. The transfer of experience through mentoring is the beginning of a culture that later evolved into writing and technology. Over time, the tools were improved. The first simple pieces of flint turned into complex knives, scrapers, and arrowheads with patterns, which made it possible to hunt and process food more accurately and efficiently. Each generation has improved processing methods by developing new forms of tools. This gradual progress is the basis for the development of human civilization. It is important to note that the tools of cavemen were an integral part of their lives. They were used to get food, protect themselves from predators, build houses, and make clothes. They symbolized the ability to adapt and use the surrounding resources with maximum efficiency. When did plants appear on Earth? The appearance of plants on Earth has become one of the key events in the history of our planet. It changed the atmosphere, the soil, the climate, and created the basis for the emergence of life on land. Today we see forests, meadows, and gardens, but billions of years ago, the world was completely different. The surface of the Earth was bare, rocky, or covered with microscopic algae. To understand when and how plants appeared, you need to plunge into the geological and biological past of the Earth. The earliest forms of life on land were microorganisms that appeared in the water. The simplest algae already existed about 1.5 to 1.6 billion years ago, and by 600 million years, algae and protozoa were thriving in the oceans. These organisms were already able to photosynthesize, that is, use sunlight to produce food. Photosynthesis not only gave plants energy, but also became a source of oxygen, which gradually filled the Earth's atmosphere, making animal life possible. The first true plants capable of living on land appeared about 470 to 450 million years ago, during the Ordovician epoch. These were primitive moss-like plants that had no roots, stems, or leaves in the modern sense. They could only grow in a humid environment because they could not effectively retain water. These early terrestrial plants were anchored to the ground using primitive threads, and nutrients and water were absorbed through the surface of the body. The next important step occurred in the Silurian, about 430 to 420 million years ago. The first vascular plants appeared. They developed conductive tissues that allowed them to transport water and nutrients up and down the plant's body. This paved the way for higher growth and for the development of land in wider areas. Vascular plants gave rise to tree-like forms, which later developed into giant ferns, horsetails, and plawns of the Devonian period. The development of plants has changed the ecosystem of the planet. They became a source of organic matter for animals, improved the soil, and created a microclimate. The roots of the plants retained the soil, preventing erosion, and the leaves formed organic residues that eventually turned into humus. These processes have prepared the Earth for the emergence of more complex forms of life. With the advent of seed plants about 360 million years ago, plants were able to colonize the land completely. Gymnosperms appeared, trees with seeds protected by cones that could be carried by wind or animals. The seeds allowed plants to survive in harsher conditions without depending on constant humidity. Later, about 140 million years ago, angiosperms appeared, the ancestors of modern flowers and fruit trees, which provided even greater diversity on the planet. Interestingly, plants have not only changed the ecosystem, but also the Earth's atmosphere. With the help of photosynthesis, they increased the amount of oxygen, which created conditions for the development of animals. Moreover, plants influenced the climate. Forests and meadows retained moisture, created shade, and cooled the Earth's surface, forming more stable living conditions. The appearance of plants has also become the basis for human development. After millions of years, they provided food, building materials, medicines, and raw materials. Even our cultural and technological achievements cannot be imagined without plants. Paper, cloth, food, wood. All these are the results of the fact that billions of years ago the first plants appeared on Earth. Thus, plants on Earth appeared about 470 million years ago in the form of moss-like forms, and then developed into vascular, seed, and flowering plants. This process has transformed the planet's surface, atmosphere, and ecosystem, creating conditions for diverse life. The appearance of plants is not just a stage of evolution, but the foundation on which all life on land rests. Every tree, grass, and flower is a part of ancient history that continues today, recalling billions of years of continuous growth, adaptation, and survival. Is it true that Mexicans are descended from Spaniards? Mexicans are a people with a rich and complex history, and the claim that they are descended exclusively from Spaniards is a serious oversimplification. In fact, Mexicans are the result of centuries of cultural, national, and ethnic mixing. To understand the origin of the modern Mexican population, it is necessary to study the history before and after European colonization. Before the arrival of the Spaniards, numerous indigenous peoples lived on the territory of the modern Mexican state. Among them, the most famous are the Aztecs, Maya, Olmecs, Zapotecs, Mixtecs, and others. These civilizations developed complex societies, had writing, religion, art, and agriculture. They built cities, roads, irrigation systems, created a calendar and astronomical observations. The culture of the indigenous peoples was diverse and very different from the European one. In 1519, Spanish conquistadors led by Hernán Cortés arrived in what is now Mexico. They conquered the Aztec Empire and gradually established control over other regions. With them came Spanish laws, religion, language, and traditions. But the Spaniards were just a small group. Their numbers were much smaller than the indigenous population. Therefore, a significant part of modern Mexicans cannot be considered Spaniards by origin in the literal sense. After the conquest, there was an active mixing of Spaniards and indigenous peoples, which led to the emergence of mestizos, people of mixed European and Native American origin. Mestizos became the main population of the central part of Mexico. Their culture combined elements of Spanish and Native American traditions. Language, religion, cuisine, music, and clothing. Over time, the mestizos became the largest ethnic group in the country, which explains the strong influence of Spanish culture that has survived to the present day. In addition, other ethnic groups lived in Mexico. In the 16th to 17th centuries, African slaves were brought here, whose descendants also contributed to the gene pool and culture. Later, immigrants from Asia, Europe, and the Middle East also added diversity. Thus, Mexicans are the result of a multi-layered mix. Indigenous peoples, Spaniards, Africans, and other immigrants. It is important to keep in mind that Spanish ancestry is often understood not only as a genetic affiliation, but also as a cultural heritage. The Mexican language is Spanish with local borrowings. The cuisine combines European and Native American traditions. Holidays and religion are Catholic, but with local elements. Therefore, the influence of the Spaniards is enormous, although it does not exclude indigenous roots. Modern DNA studies show that Mexicans have varying percentages of European, Native American, and African genes, depending on the region. Mestizos with a significant Spanish heritage predominate in the central part of the country. There are more people with indigenous roots in the southern regions. There are more Europeans in the north. African genes are found mainly on the coasts. Such a diverse genetic map reflects the history of colonization, migration, and cultural mixing. Thus, the claim that Mexicans are descended from Spaniards is an oversimplification. In fact, the modern Mexican is a complex mix of cultures and peoples, where indigenous Indian roots are combined with European, African, and other heritages. The Spaniards left a deep cultural mark, but the Mexicans are genetically a product of a centuries-old history of interaction between different peoples. Mexicans are proud of their diversity. Their culture is a unique blend of indigenous traditions and Spanish heritage. This makes Mexico a country with a rich history, where every feature, every tradition, and every holiday reflect a centuries-old mix of civilizations, rather than a single origin. The history of Mexicans shows how culture and genes intertwine, creating a unique nation with its language, art, and worldview. Why wasn't America named after Columbus? When we study the history of the discovery of America, we often hear that Christopher Columbus discovered the New World in 1492. However, the continent is not named after him. Why did the world decide to immortalize not Columbus, but the name of Amerigo Vespucci? The answer has to do with cartography, the popularization of ideas, and the specifics of the time when Europe first learned about the new continent. After Columbus sailed, Spanish maps designated the lands he discovered as the Western Indies. Columbus was convinced that he had reached the shores of Asia, so the names India and Western Indies were fixed on the maps. At that time, the term America did not yet exist. Columbus left detailed records of his travels, but they spread slowly, and his discoveries were not immediately recognized as the discovery of a new continent. Amerigo Vespucci, a Florentine navigator and explorer, traveled to the southern shores of South America in 1499 to 1502. He concluded that the lands discovered by Europeans are not part of Asia, but represent a new continent. Vespucci wrote letters and reports about his travels, which quickly spread throughout Europe. His observations proved clearer and more convincing to cartographers of the time than Columbus's work. In 1507, German cartographer Martin Waldemüller created a world map where he first used the name America in honor of Amerigo Vespucci. He noted that Vespucci was the first to realize that the open lands were a separate continent, not Asia. It was this fact that became the reason why the world decided to name the New World after Vespucci and not Columbus. Interestingly, the role of cartography was crucial. In the 15th to 16th centuries, maps were not only a navigation tool, but also a means of spreading knowledge about the world. Waldemüller's maps became widespread, and the name America gradually gained a foothold. It is important to understand that the decision to name the new continent after Vespucci was due to recognition of his discoveries, and not to subjective popularity. Columbus, despite his achievements, did not receive such recognition, for several reasons. He insisted that he had reached Asia and did not realize that he had discovered a new continent. His reports were less convincing to European scholars of the time, and his personal reputation suffered due to administrative conflicts in the colonies. As a result, Columbus's name remained famous, but was not assigned to the continent. The political aspect is also worth noting. In the 16th century, various European countries claimed to discover the New World. Spain promoted its maps and colonization data, but Germany and Italy actively disseminated information about Vespucci's travels. Thanks to this, the name America appeared on the international map, and the popularization of ideas through printed letters and reports ensured widespread recognition. Over time, the term has become entrenched. North and South America began to denote continents, and Vespucci's name became a symbol of geographical discovery. Curiously, in some European languages, the variant Amerigo or Americ is still sometimes used, while maintaining a historical connection with the navigator. Thus, America is not named after Columbus because Amerigo Vespucci played a key role in recognizing the new continent. He was the first to realize that the open lands were a separate continent, not Asia, and his reports became widely known through cartography and printed letters. The decision to fix his name on the map was the result of the scientific, political, and cultural process of that time. Today we take the name America for granted, but behind it lies a history of discovery. Vespucci's powers of observation, and the influence of Renaissance cartographers. This reminds us that sometimes honor and memory are assigned not to the discoverer, but to the one who correctly explained and brought the discovery to the world, turning it into a historical fact. Who discovered atoms? An atom is a fundamental unit of matter, and the history of its discovery is one of the key moments in the development of science. The idea that everything is made up of tiny particles existed long before the advent of modern science. The first thoughts about atoms belong to ancient philosophers, and real discoveries in physics and chemistry occurred only in the 19th and 20th centuries, when experimental methods made it possible to test theories and understand the structure of matter. The first to propose the idea of the atom was Democritus in the 5th century BC. He claimed that everything consists of indivisible particles, which he called atomos, that is, indivisible. Democritus believed that these particles vary in shape and size, and combine to form different substances. This idea was purely philosophical, not confirmed experimentally, and for many centuries it was perceived more as a thought experiment than as a scientific fact. In the 17th and 18th centuries, philosophical concepts were supplemented by chemistry. Scientists have noticed patterns in the reactions and properties of substances. John Dalton, an English chemist and physicist, developed the first scientific atomic theory in the early 19th century. He suggested that all substances consist of atoms that cannot be divided by chemical methods, that each element has atoms of the same type, and the atoms of different elements differ. Dalton's theory explained the laws of conservation of mass and constancy of composition, and became the basis of modern chemistry. By the middle of the 19th century, scientists began to discover the internal structure of the atom. In 1897, the English physicist J. Thomson discovered the electron, discovering that the atom is not indivisible, but contains the smallest charged particles. Thomson proposed the pudding with raisins model, where negative electrons are embedded in a positively charged sphere. This was the first step towards understanding atomic structure on an experimental level. The next important step was taken by Ernest Rutherford in 1911. He conducted a famous experiment with gold foil, directing alpha particles at it. Most of the particles passed through the foil, but some were reflected back. Rutherford concluded that an atom consists almost entirely of empty space, and all the positive mass is concentrated in a small nucleus. This is how the structure of an atom with a nucleus and electrons was discovered, which became the foundation of nuclear physics. In 1913, Niels Bohr proposed a model of an atom with electrons orbiting the nucleus. His model explained the spectra of hydrogen and the laws of quantum mechanics, paving the way to a modern understanding of the atom as a complex system, obeying not only the laws of classical physics, but also quantum rules. Later discoveries included the neutron, discovered by James Chadwick in 1932, which made it possible to fully describe the composition of the nucleus, protons and neutrons. Modern science considers an atom as a system, with a nucleus, electrons interacting through electromagnetic forces, and quantum states that determine the properties of matter. Interestingly, the discovery of the atom is not the merit of one person. This is the result of centuries of development of ideas, from the philosophical reflections of Democritus, through the chemical research of Dalton, the experiments of Thomson and Rutherford, to the quantum mechanics of Bohr and subsequent research. Each step revealed a deeper and deeper structure of matter, and showed that an atom is not just an indivisible particle, but a complex system with a nucleus and a cloud of electrons. Understanding the atom has changed the world. It provided the foundation for modern chemistry physics, materials science, nuclear energy, and technology, chemical reactions, material properties, and even biological processes in living organisms depend on microscopic processes in an atom. How far is it to the stars? When we look at the night sky, it seems that the stars are directly above us, as if they are hanging on a black dome. But in fact, the distances to the stars are enormous and almost unimaginable for human experience. To understand how far away the nearest stars are, you need to consider astronomical units, light years, and the scale of the universe. The closest star to Earth other than the Sun is Proxima Centauri, a red dwarf in the Alpha Centauri system, located about 4.24 light years away. A light year is the distance that light travels in 1 year, traveling at a speed of approximately 300,000 kilometers per second. Even at this incredible speed, it takes more than 4 years for light to travel from Proxima Centauri to us. For comparison, the light from the Moon reaches the Earth in just 1.3 seconds, and from the Sun in about 8 minutes. When astronomers measure distances to stars, they use different methods. One of the main ones is parallax. That is, the displacement of the apparent position of a star relative to the background of more distant stars as the Earth moves around the Sun. The closer the star is, the greater its parallax. This method works for stars up to several thousand light-years away. For more distant objects, other methods are used. For example, measuring the brightness of standard candles, such as Cepheids. The incredible scale becomes clear when compared with the solar system. For example, Pluto is about 5.9 billion kilometers away, which is about 0.00062 light-years. That is, the nearest star is about 6,800 times farther away than Pluto. And this is only one step towards understanding the size of the galaxy. The Milky Way, our galaxy, has a diameter of about 100,000 light-years. The stars that we see with the naked eye are within a few thousand light-years. But the galaxy contains hundreds of billions of stars, and most of them are tens of thousands of light-years away. And beyond the Milky Way are billions of other galaxies whose distances are measured in millions and billions of light-years. These scales are amazing. Even if we send a spacecraft with the speed of modern technology, such as Voyager 1, which is moving about 17 kilometers per second, it will take tens of thousands of years to reach Proxima Centauri. This shows how vast the distances in space are, and how limited our ability to travel between the stars is with current technology. Understanding the distances to the stars is important not only from the point of view of science, but also for astronomical navigation and research. By measuring distances, scientists can determine the luminosity of stars, their mass, temperature, and age. It helps to build models of galaxies, understand the formation of stars, and the evolution of the universe. In addition, knowing the distances to the stars allows you to realize the scale of time and space. The light we see from a distant star can take millions of years. We see it as it was in the past, and sometimes as it looked before civilizations were formed on Earth. Looking at the night sky, we are actually looking into the past. Finally, the concept of distance to the stars expands our understanding of humanity's place in the universe. The Earth is a tiny dot among billions of stars, but the ability to measure these distances, build telescopes, and send spacecraft to outer space shows the unique capabilities of the mind. We can comprehend the scale of the universe, even if traveling to it remains almost impossible. Thus, the stars are located at enormous distances, measured in light years. The nearest ones are only 4 light years away, and the rest are thousands, millions, and billions of light years away. These scales make it clear that space is huge and amazing. Looking at the night sky, we see not just points of light, but distant worlds and epochs that remind us of the greatness and vastness of the universe, as well as how little we can still travel among the stars. Why is there no life on the moon? The moon, the closest satellite to Earth, has long attracted the attention of mankind. We dreamed that creatures could exist on its surface, as in fantasy stories. But in fact, the moon is absolutely unsuitable for life in our usual understanding. There are several reasons for this, and they are related to the lack of an atmosphere, water, a magnetic field, and a suitable temperature. First of all, the moon has almost no atmosphere. The Earth's atmosphere protects living organisms from cosmic radiation, maintains the pressure necessary for the existence of liquid water, and contains oxygen, which is used by most living beings. The lunar atmosphere is extremely thin and consists of individual atoms and molecules, mainly helium, hydrogen, and a small amount of argon. The pressure on the moon's surface is millions of times less than Earth's, making it impossible to breathe and keep water in a liquid state. The absence of an atmosphere leads to another problem: the lack of protection from solar radiation and meteorites. On Earth, the ozone layer and magnetic field deflect harmful ultraviolet and cosmic rays. There is no such protection on the moon, and solar radiation reaches the surface directly, causing the destruction of organic molecules. Any living organism on the surface would be instantly destroyed by radiation. The temperature conditions on the moon are also extremely harsh. Daytime temperatures at the equator can reach plus 127 degrees Celsius, and nighttime temperatures can drop to minus 173 degrees Celsius. The difference between day and night reaches hundreds of degrees in 14 Earth days. Such fluctuations make impossible the stable existence of liquid water, which is necessary for all known forms of life. Even microorganisms resistant to extreme conditions on Earth would not be able to survive without protection. Another factor is the lack of liquid water. On Earth, water is the basis of all living organisms. On the moon, there are only traces of frozen water in the dark craters at the poles, where sunlight barely reaches the surface.
But the availability of this water is extremely limited, and it cannot support the ecosystem. Without water, life in its usual form is impossible. In addition, the moon lacks a dense magnetic field, which on Earth protects the atmosphere and surface from the solar wind. On the moon, the solar wind directly blows away atoms from the surface, making the atmosphere even more rarefied and uninhabitable. Any attempt at the existence of a living organism on an open surface without a protective environment is doomed to failure. Interestingly, there is no biological basis for maintaining the circulation of substances on the moon. On Earth, living organisms and plants create ecosystems by recycling substances and maintaining a balance of oxygen and carbon. There is no soil, microorganisms, or atmosphere on the moon to form a biosphere. This makes it impossible for even primitive ecosystems to exist. Nevertheless, the moon is interesting to scientists because it can store traces of life that came from Earth. Meteorites ejected from Earth into space could transfer microorganisms to the moon. Although they did not survive in open space, studying such objects allows us to understand how life can spread across planets. In practice, this explains why astronauts used spacesuits and protected modules during moon landings. All the equipment had to create an atmosphere, maintain the temperature, and protect against radiation. Without such conditions, no living organism could exist on the surface of the satellite. Thus, there is no life on the moon, because it lacks an atmosphere, water, stable pressure, a magnetic field, and a suitable temperature. These factors make it completely unsuitable for the existence of organisms familiar to us on Earth.
The moon is a rocky, dry, and extremely cold or hot world where life is possible only in artificial conditions created by humans. Studying it helps to understand what conditions are necessary for life and how unique the conditions of the Earth are. Which mountains are the highest on Earth? When we talk about the highest mountains on Earth, the Himalayas usually come to mind, and in particular, Mount Everest, which, with a height of 8,848-86 meters, is considered the highest point on the planet. But the concept of highest can have different meanings: height above sea level, height from the base, or relative height. Let's look at these categories to understand which mountains are really leading in terms of scale. The most famous record holder is Mount Everest in the Himalayas. Its peak reaches 8,848.86 meters above sea level, and it is a symbol of human achievements in mountaineering. The Himalayan range was formed as a result of the collision of the Indian and Eurasian tectonic plates about 50 million years ago. The pressure and movement of the plates lifted the granite and metamorphic rocks by thousands of meters, creating a chain of many of the world's highest peaks. However, if we look at the mountain from its base to the top, the record may belong to another object. For example, Mauna Kea in Hawaii, a volcano that rises underwater from the seabed, has a height of more than 10,000 meters from the base to the top. Although Mauna Kea is only visible at 4,207 meters above sea level, its full vertical extent makes it the largest mountain on the planet in absolute height. Interestingly, there are other indicators of height. Mount Chimborazo in Ecuador is the closest to the stars, considering the shape of the Earth, a geoid. Due to the Earth's equatorial bulge, Chimborazo Peak is 6,384 kilometers away from the center of the planet, which is several kilometers further than Mount Everest. This means that Chimborazo Peak is ahead of all other mountains in terms of distance to space. Mountains are formed by various geological processes. The Himalayas are the result of plate collisions. Volcanoes, such as Mauna Kea, occur when magma accumulates and forms a cone.
Old mountain ranges, like the Appalachians in North America, were once taller, but millions of years of erosion have reduced their height. Thus, the highest mountains depend on criteria: absolute height, altitude above sea level, or distance to the center of the Earth. Besides Everest, there are other giants in the Himalayas. K2, 8,611 meters. Kangchenjunga, 8,586 meters. Lhotse, 8,516 meters. These peaks are considered to be among the most difficult to climb due to steep slopes, avalanches, weather conditions, and thin air. Climbing such mountains requires careful preparation and acclimatization. The highest mountains are not only an object of records, but also a key element of ecosystems. The Himalayas shape the climatic conditions of South Asia, regulate precipitation, and feed the largest rivers. The high mountains contain glaciers that provide fresh water to millions of people. Volcanic mountains, such as Mauna Kea or Fujiyama, create fertile soils and unique ecosystems. Scientific research of high mountains helps to study geological processes, climatic changes, and glacial movements. For example, measurements of the thickness of glaciers on Mount Everest show how melting affects the region's water resources. Geologists study uplifted rocks to understand the history of plate collisions and the evolution of mountain systems. The mountains also have cultural and spiritual significance. The Himalayas are sacred to the local peoples, and Everest is known as Chomolungma, the mother of the universe. In Japan, Fujiyama is considered a sacred mountain. For centuries, people have admired the greatness of the mountains, climbed to the peaks, and created myths, legends, and scientific research. Thus, the highest mountains on Earth are Mount Everest in height above sea level, Mauna Kea in absolute height from the base, and Chimborazo in distance to space. Each mountain is unique, geologically, climatically, and culturally. Their study reveals the history of the Earth, the processes of planet formation, and the role of mountains in ecosystems. And climbing the peaks remains one of the greatest human challenges. Why don't different countries have the same money? Money is a universal instrument of exchange, but each country uses its own. It would seem that it would be more convenient to have the same money all over the world, but in practice, this is impossible due to economic, political, and cultural reasons. Different currencies reflect the history, economy, national interests, and sovereignty of states. First, every country strives to control its economy. Currency is an instrument of monetary policy. Central banks can influence inflation, interest rates, and money supply by regulating economic activity. If all countries used the same currency, the individual policy of each state would be impossible. For example, to combat the crisis, a country needs to lower interest rates or print money. And in a single currency system, this decision
would have to be coordinated with all participants. Secondly, money reflects national identity. The banknotes and coins depict historical figures, monuments, national symbols, and outstanding events. This helps to create a sense of belonging to the country. Imagine if there would be the same money everywhere. The possibility of cultural expression through the symbolism of currency would disappear. The national currency has become part of the identity, like a flag or an anthem. Historically, currencies were formed from local exchange systems. Previously, trade was conducted in goods and metals, gold, silver, copper. Over time, each country minted coins with a certain weight and content of the precious metal. Different coins reflected the economic power of the state and the trust in its authority. When paper money appeared, the differences persisted because each country issued banknotes under its own economy and tax system. There are also geopolitical reasons. Currency is an instrument of influence. Strong states can impose trade in their own currency. For example, the US dollar and the euro are used not only within their countries, but also in international trade. However, each country tries to maintain control over its own currency in order not to depend entirely on the economic policy of another state. Some countries share the same currency. For example, in Europe, there is the euro, which unites more than 20 countries. But even here, each country participates in the common policy of the European Central Bank, which requires coordination of economic measures. This model shows that sharing money is possible, but only with a high level of integration and readiness for a common economic policy. Different currencies are also related to the economic situation and the level of trust. The value of money is formed in the market. Exchange rates change depending on demand, supply, and stability of the economy. If all countries used the same currency, its value would have to take into account the conditions of all economies at the same time, which is extremely difficult. Different money allows you to adjust the cost to local conditions. Finally, there are technical and historical reasons. The currency is linked to the national banking system, tax, and financial infrastructure. Replacing all money with one global system would require a complete restructuring of these structures, which is almost impossible. In addition, people are used to their own currency, which makes the transition to a single currency psychologically and socially difficult. Thus, different money exists in the world due to a combination of economic, political, historical, and cultural factors. Currency is an instrument of control over the economy, a symbol of national identity, and a reflection of trust in the state. It has been formed over the centuries and is adapted to the specific conditions of each country. What is witchcraft? Witchcraft is a concept that combines magic, belief in supernatural powers, and practices aimed at influencing events, people, or nature. Since ancient times, people have tried to explain incomprehensible phenomena, diseases, crops, weather, and business success through actions that go beyond ordinary physical reality. Witchcraft manifested itself in myths, religions, rituals, and folk beliefs, and its meaning varied greatly from culture to culture. Witchcraft is based on the idea of influencing the world through magical actions. These can be spells, amulets, rituals, potions, herbs, and various items that are attributed special powers. In ancient times, people believed that words and actions could change the course of events, protect from danger, or harm the enemy. Witchcraft was considered a part of everyday life. It was used for healing, predicting the future, and providing good luck. There are several types of witchcraft. White magic is aimed at doing good, protecting people, treating diseases, and attracting good luck. Black magic was used to inflict harm, curse, or control someone else's will. In addition, there was folk witchcraft associated with customs, omens, and local traditions, and ecclesiastical witchcraft, which was condemned by religious institutions, but sometimes included elements of rituals for healing and protection. Historically, attitudes towards witchcraft have changed. In ancient cultures, witchcraft was perceived as knowledge and the ability to interact with the forces of nature. In the Middle Ages in Europe, witchcraft was often considered heresy and the cause of misfortune, which led to witch hunts. People were accused of witchcraft for accidents, illnesses, or crop failures, and the punishments could be fatal. In some cultures, the accusation of witchcraft served as a way to intimidate, regulate power, or explain obscure events. A scientific perspective explains witchcraft as a psychological and social phenomenon. People have always sought to control the world around them and explain random events. Rituals and magical actions gave a sense of control and confidence. Symbols, amulets, and spells served as a form of psychotherapy. They helped to cope with fear, anxiety, and uncertainty. Witchcraft is also linked to a worldview and culture. It manifests itself in different ways in different countries. In Africa and South America, traditional forms of magic and shamanism are still practiced, combining them with religion. Historically, Eastern Europe has had a rich tradition of folk magic, spells, and rituals used to protect against evil spirits and diseases. In Japan and China, witchcraft was intertwined with religious and philosophical teachings such as Taoism and Shinto. Interestingly, in the modern world, witchcraft exists not only as a religious or magical practice, but also as a cultural and artistic image. Literature, movies, and games use witchcraft to create myths, legends, and fantasy stories. It has become a part of folklore and popular culture, preserving the symbolism of influencing the world in supernatural ways. Philosophically, witchcraft reflects a person's desire to control the unpredictable, to seek explanations and control over fate. It combines the material
and the spiritual. Real actions and faith in invisible forces. For practitioners of witchcraft, intuition, knowledge of nature, and ritual precision are important. Thus, witchcraft is a complex of magical practices, beliefs, and rituals aimed at influencing the world through supernatural means. It has deep historical, cultural, and psychological roots, and manifests itself in various forms in different societies. Witchcraft reflects the human need to explain the incomprehensible, control events, and seek protection or strength in the invisible world. From the point of view of science and history, it is simultaneously a phenomenon of faith, culture, and psychology, which continues to influence our perception of magic and the supernatural.